Greetings, everyone. I'm not on the bench this morning. I'm actually across from the bench. This is my exercise bike, and I seem to be having issues with it. Well, first of all, apologies for not having a lot of videos up. I was on vacation last week. When I got home, came home to a bunch of work, so I got all that to do. But one thing I don't miss is my workouts. And my exercise bike is part of my workout regimen. You know, I want to be in shape when I get older. I don't want to be stuck in a chair and watching TV. I want to be doing stuff. Because, you know, it's a lot to life and I want to enjoy it. So I've always worked out. And I ride the exercise bike about 40 minutes for 3 times a week. Like I say, it's part of my workout. And I've used it for a long time. It's actually lasted very long, but it's kind of wearing out. The bearings are getting a little wonky. And I put a new chain on it last year. The other chain was hopelessly stretched. Chain doesn't really stretch, it's just the little pivot bearings wear out and it makes the chain longer than it's supposed to be, and it doesn't fit the cogs right anymore. But, well, that's not the issue. The issue is the alternator. It doesn't seem to hold. You have to run this at a minimum speed or the power goes out. And phone's ringing. Okay, so before I was so rudely interrupted, so how this thing works, well, you know, an alternator does not have any permanent magnets in it. So if I just started pedaling, I would get nothing out of it. So I have this little capacitor here that stores a little charge. So I start pedaling, hit the button, and that gives a little jolt to the field winding in there, and that starts producing electricity. And once that's going, it feeds the electricity back into the field winding, so it now can sustain its own generation of electricity. Now this is a 3-phase device, and I like this design. I can pick off one of the phases here and I run it through this transformer I custom wound. Ignore this other stuff just sitting here, it's not connected. And that produces 120 volts. And it's just something I made. It goes into this light bulb. It acts as a bit of a load. Most of the power actually goes back in to generate the magnetic field. I also have this fan. It's a 12 volt fan. It blows on me as I'm pedaling. Helps keep me cool. So yeah, it's this kind of a interesting way. Instead of just having a, you know, normally these exercise bikes, they'll have a belt or some sort of friction device to, you know, give you some resistance. But this uses electricity, generates electricity to give you resistance. Anyhow, to cut to the chase, you have to have a minimum, you know, speed you keep going here, or when you fall below that, it stops generating electricity. Well, now I can pedal harder, and it drops out on me. And I was doing fine. I was like 15 minutes in, and then it just started dropping out on me. So something happened. I don't know what's wrong. I squirted the slip ring in there with contact cleaner. Hopefully I can finish my workout, but no, I can't do it. So something's wrong here. Let's see if I can get on here and, you know, make it run. Well, I tried already. I can't even get it to start. I did check. I pre-charged the cap with 12 volts. Normally, when you speed it up, hit the button, it'll get the generation going and give the cap a little bit of charge. So I don't have to do anything. You know, the next time I ride it, I just get on and hit the button. But I made sure it has 12 volts on the cap. I mean, you can start with less than that. So I will speed it up here. And nothing. It won't even start now. I don't know what's going on. Could be something stupid as a dirty connection, but yeah, let's see what's going on with this thing. I'm connected to the armature or the field winding. It's the actual electromagnet. And as I move this thing, I seem to have like a dead spot. So now it's connected. Yep, another dead spot. Maybe maybe the brushes are worn out because I keep hitting dead spots here. See, now it's open. And I'll move it. Now it's connected. Open again. Open. So, yeah, that's probably the problem there. Let's open this thing and see what kind of condition here. I think I can take the brushes out just by loosening the screws here. I can't do this with one hand. Yeah, looks like there's plenty of material on there still. Guess I'll take the alternator apart and see what's going on inside there. Okay, I got it cracked open here. Here's the slip rings. I think it's just dirty, but it's cracking here. I don't know if it'll show up. Yeah, it's about done. Still should make contact. I think I can get it working until I can get another alternator. Gotta get a replacement. If I get the light angle just right. Yeah, this is cracking. This doesn't look serviceable though. You can't replace this part. There's the other slip ring. It's got grease all over it. I greased this bearing a couple years ago. I think I was a little overzealous. Maybe got grease on the slip ring. This is probably it's just all gunked up. Yeah, I think I'll try cleaning this. Maybe even light sanding it. Getting it cleaned up. Maybe it'll work again until I can get a new alternator. So I degreased these contact surfaces. Then I took a real fine sandpaper. Started bringing out the copper again. But as I was doing that, I noticed this. I didn't see it before. See, this is one contact surface where the brush contacts, and then one comes in at the side, right here. And look, all that copper is gone. It's worn away. It's gone. Look at that. And no wonder it doesn't work. It's like 1/3 of the circle is gone. So this is not replaceable. I'm going to have to buy another alternator, another remanufactured alternator. And I got 20 plus years out of this one. Okay. Local place had an alternator. It was about 90 after taxes, so yeah, not too bad. I think when I bought the other one about 30 years ago, 1992, it was 65 bucks. So yeah, it's not too bad. So, it's a remanufactured. I gotta put the camera down. it won't come out of the packaging. Maybe it will. Okay. Yeah, looks just like it. Nice and clean. I think I'll open it up just to take a look inside. I don't know how good these modern remanned alternators are. Windings look crappy though. Look like they're burned. Huh. Okay, well I guess they paint it. That's black paint because it's not burned on the inside. So yeah, I thought the windings were crispy, but that's just paint. Plenty of grease in the bearings there. I got the roller bearings. You see that there? I checked the 6 diodes and they look good. I wonder what that is, like a capacitor or something. Nice new bearing surfaces. Nice bearings. I can't spin it here holding the camera, but they feel nice and smooth. Okay, so I'm going to put this back together and put it on the bike. Okay, I got it mounted back on the bike here. And most of the wires connected up. I have to do something with this one though. So what I want to do is take it on a test run here. I have one problem already. This pulley is not out that far and it's dragging on this. I wonder if this thing is perpendicular to the base. Maybe it needs adjusted or something. But yeah, not much I can do about that. That's one issue I need to deal with. Let's see how it works. So I'll climb on the bike here holding the camera. I'll spin it up and press the button. It works. Got some fan action. But it's like I'm climbing a hill. It's like I'm pedaling up a steep hill. And at that pedal rate, I want it to be more like riding on a slight incline. So yeah, the resistor pack here I use to regulate current going into the field coil is letting too much current in. It's the same one I used on the other alternator, so perhaps the resistance of the field coil is a bit different. Normally these have a regulator on them, and you might be asking, why don't you just use a regulator? Well, I want this thing to have more resistance as I speed up. You'd have some with a regulator, but the way it worked before, if I rode at a slower speed, I wouldn't get as much tension. It'd be like riding on nearly flat or a slight incline. But during the workout, I wanted to, for more aerobic effect, I wanted to, speed up for more resistance. So the resistor pack, allowed that to work pretty seamlessly. But with that same pack on there, it's too resistive, or there's too much resistance for pedaling. Not electrical resistance, but pedaling resistance. Just running at a slower speed. So I need to play around with this thing and see if I can dial it in. Okay, desoldered one of these resistors. So now it's just 1 ohm. It will probably run pretty hot, but Oh well. That's just the way it is. And this was tilted a bit forward into the belt, so I bent it back a little bit so there is better clearance now. It's a little tight down here still, but as long as it's not rubbing. Much better. I'm cruising along now. So if I go faster, yeah, I can feel the tension build up. The voltage builds up. Just have to see how that works. Okay, so this is how this thing works. So this is the actual alternator itself. And you have the stator, which is the three-phase wound coils, and the rotor, or in this case, the filled coil, which is the rotating part. Also, inside the case of the alternator is this three-phase full-wave bridge. And you can see how each leg of the phase is connected to that, and you get your DC on the outside. Now the design of that alternator, it has those vents near the diodes, and I can connect a transformer to one of the phases before those diodes. That's how I get that high voltage out for the light bulb. So it's around 120 volts, but of course it varies with the speed. Now this filled coil needs to have current going through it to produce magnetism so the alternator can produce electricity. And it's actually feeding itself electricity to do that. But it does not produce electricity on its own. I mean, at the start, if I just get on the bike and pedal, it does nothing. There's no electricity output here. So what I do is I have this capacitor and a momentary switch across the filled coil. So what I do is I start pedaling, I push this button which closes a circuit, and that gives a jolt of current through the filled coil, and that immediately starts electricity being produced. Before I can remove my finger from the momentary switch, that current replenishes this capacitor so it's ready for the next start. And now this is taken out of the circuit as I'm pedaling and it's generating electricity. Now to prevent backfeed from this capacitor into any loads that I connect to the DC output, I have this diode here because I only want the capacitor to discharge through the filled coil. And that resistor, as I explained earlier, this limits current going into the filled coil, so it matches up with the gearing, the gear ratios of the bike. So as I pedal, I'm getting the desired resistance against the pedals as I run the bike at various speeds. With the old alternator, I was using 0.5 ohm, but when I did that, I was getting too much resistance because maybe this coil is wound a bit differently and was producing more magnetism, so I backed that off to 1 ohms, and it matches the pedal resistance of the old alternator. As far as the 12-volt loads, of course, they'll be connected here like the fan is connected at this point. So that, in a nutshell, is how my little electric exercise bike works. And that will wrap it up for this one. Thanks for watching.